right, this is the cliff problem from the peer deck. For period 1, I think I have a little different numbers in period 2 and 5, but you can just plug the numbers right in. I'll go over the answers at the end for period 1 as well, but I'm going to do the numbers from period 2 and 5. And so a cliff problem. Now, what's different about this problem compared to the others is we have the X direction and the Y direction. So we have a horizontal component and a vertical component. So what makes these challenging is, one, we have to identify the values that we're given. Are they for the X direction or Y direction? And then when we solve for something, making sure we only use, if we're solving for something in the Y direction, I can only use Y direction values. I can't use numbers from the X direction over in the Y part. They can be compartmentalized. Look only at the Y stuff, look only at the X stuff. The only exception to that is time. Time is consistent in either direction, so you can use that value when solving for either. All the other numbers, though, you cannot. All right, so something to keep in mind. All right, so you got a remote control car that can get to 20 meters per second, and it is trying to get over a 25-meter divide, and it's going to drop 10 meters in the process. Right? Does it make it? How fast is it going? How far does it go? Are things that we're going to have to figure out. So some of the initial stuff for every cliff problem. What can we figure out? All right, now we got both directions, and nothing has changed in terms of our acceleration in the Y direction. It's always -10. No matter what acceleration due to gravity, the Y direction will be -10 for these projectiles. In the X direction, we're always working with constant velocity in the X direction, so I know my acceleration must be 0. And the other thing that we know is that as something is rolling off a cliff, let's say, whatever that is, for that instant it leaves the edge of that cliff, the velocity in the Y direction is 0. Even though it's going to be traveling this way, it's going to be picking up speed in the Y direction. Once it leaves the edge of that cliff, we know the vertical velocity, the initial vertical velocity is going to be 0. So those are 3 things right off the bat I need to put in for every single cliff problem because they are important to solve. Next thing we do is we take what's from the problem. All right. And so we know that the initial velocity in the X direction when this object is traveling, and just to make sure we understand what's going on, I'll do a little. All right, it's going to be traveling this way. All right, we know that this is 25 meters, and we know that this drop between these is 10 meters. All right, and the velocity is 20 meters per second going that direction. All right. So this is the information we know. We know that he's going to drop 10 meters down, and that's going to be a -10. So we know that to be true. We also know that if it's constant velocity, because there's no acceleration, that the initial and final in the X direction are going to be the same. In this case, 20 meters per second. So now we really have very little left to solve for. We got 3 variables that we need to figure out. Okay, the time, the displacement, how far they actually traveled. And don't be mistaken, this is where people can get hung up on this to think, oh, it's 25. It says 25 in the problem. No, that's how far the gap is. We need to calculate if they made it or not. Right? So if we calculate that it was less than 25, the car didn't make it. If it's more than 25, then the car made it. All right, so that's what we're going to try to figure out. We're going to try to figure out that displacement problem. All right. And so sometimes when we are trying to solve these problems, let's say we want to try to solve that displacement problem. All right, well, we got the X here. Well, then we run into, well, I don't know how long it's been in the air. I don't have the time. So that presents problems. I don't know what the vertical velocity is because this is going to be constant. So I really can't use this in the X direction because it's going to be 0 and these are going to be the same. It doesn't really seem to work real well. Now, I have to think, all right, what can I solve? And so here's the thing. Whenever you get stuck, and it's easy to get stuck on these types of problems, find anything that you think I can solve for. Even if it's not the question they're asking, maybe you have to answer something first and then take information from that to solve the question you were asked. All right, so in this case, we want to figure out if it made it or not. But we really need to solve for time. All right, so again, remember, I can only, even though I'm solving for time, whatever equation I decide to try to use, I can only use stuff from either the x or the y. I cannot use things from both. All right, so let's take a look and see if we can figure out time. All right, we tend to use this equation to solve for time or the one above it, but we don't have a final velocity, we don't have time, so we can't use this one. Well, let's see if we can use this. All right, we got our displacement. Well, we know that's actually, because we're using the y direction stuff, is -10. My initial velocity in the y is going to be 0t, so that's great because it eliminates that term. And then I got -10 times t squared. All right, great. This is good. So I take 1/2 of -10, that's -5, so I'll divide by -5 on both sides. Also good because my negatives will cancel out, giving me 2 equals t squared. I will take the square root of both sides. I'll get 2 is the square root of 2, which is also, if you plug it into your calculator, approximately 1.4 seconds. All right, so we'll use 1.4 because using radicals sometimes it's just not fun to do, so we'll keep that away. So it's in the air for 1.4 seconds, so that applies to the x direction and the y direction because time does that. So that's really good. So now we have another value we can use to solve in the x direction. So let's see if we can figure out what the displacement in the x direction is. All right, so we just used that equation, but now we can use it to find something else because we're using x values only. I don't know what this is in the x direction. I do know my initial velocity is 20 because it says that. I now figured out what my time was. All right, so I keep looking only at the x, and I see a is 0 in the x direction. And then 1.4 squared, 0 eliminates that entire term. So awesome, we have a constant velocity problem, just like our first unit, which is one of the things about cliff problems. It's really kind of a dropping problem plus a constant velocity problem. So this is our constant velocity part. 20 times 1 is 20, and 0.4 of that, okay, is basically times 2 is 8. Add those together, 28 meters. So yes, in this case, they made it. Okay, and then for period 1, all right, we had to see if it's went a 15-meter divide, and it did because it went 20 meters. So this would be 20 in for period 1, and the time would have been 1 second. And so it made it for all classes. But yes, for periods 2 and 5, it went 28 meters. Okay, so now we're trying to figure out one last thing of how fast was it going in the y direction. So we know it was traveling at 20 meters per second to the right, but we don't know what the vertical velocity was right before it hit the ground. And so we're going to take a look at this. We know it's 0 plus -10 times 1.4. My final velocity in the y direction will be -14 meters per second, which makes sense because it's going downward. It's accelerating at -10 meters per second. It's only in the air for 1.4 seconds. That seems very plausible. All right, so this is how you would do most cliff problems that you see. Check it out. Try and do it from scratch. If you feel like you're still lost, watch it again. Stop it. Be able to replicate this stuff. Don't just watch and say, "Oh, yeah, that makes sense." Watch it and then take a look at the problem separately with a blank sheet of paper and try to recreate it. That's important because it kind of ingrains in your mind a direction and a route to get to the answers you need. Values that are given to you because it's a cliff problem. Values that are given to you in the problem. And figuring out ways that we can solve for these things. All right, so you got to put some practice in, but it will pay off. Any questions, please let me know.